Why do most traders fail? It's usually blamed on psychology or bad luck. But beneath the surface lies a mathematical trap that most professionals ignore. Today, we're looking at the hidden math of risk and why your average win doesn't matter if you don't understand the difference between expected value and logarithmic returns. Now, imagine a trader with a 60% win rate. On paper, they should be wealthy, right? But in these simulations, most lines end in ruin. Despite the probability being on their side, they drift towards zero. Why does a math positive game feel like a slow motion car crash? Let's look at the rules. Now, in this game, every win yields 50% and every loss takes away 60%. With a 60% win rate, your arithmetic expected value, which is the average result, is 6% per trade. On Wall Street, an edge like that is gold. But there's a trap here, a multiplicative one. Compounding is multiplicative. If you win once and then lose once, you don't end up with 50 minus 60 minus 10%. You end up at 0.6, 40% net loss. This is the asymmetric recovery problem. One win and one loss doesn't bring you home. It drags you down. And math is symmetric on paper, but it's aggressively asymmetric on your wealth. In this graph, the dashed line is our 6% expectation. But look where the typical outcomes cluster. While the theoretical expected value is skyrocketing, almost every real-world trader in this simulation is hitting the floor. We are confusing the average result of all parallel worlds with the typical experience of one person playing over time. So, to see the truth, we must look at log returns. When we transform outcomes into the logarithmic domain, the reality is revealed. Our average log return, the actual growth rate of our wealth, is negative 0.12. Now, in a multiplicative world, a positive expected value can easily hide a negative growth rate. But this is the core distinction. Expected value is a group average, but you live in one timeline. So, therefore, this is the ergodicity problem. In your specific universe, the typical path, you're slowly eroded by the volatility which you thought was the engine for growth. Now, total loss is an absorbing state. Once you hit zero, the math stops. You cannot multiply your way out of nothing. Because your growth rate is negative, every trade brings you statistically closer to the boundary. Eventually, ruin becomes your only inevitable outcome. This brings us to the Kelly Criterion, the formula for optimal bet sizing. For this specific game, the maths returns a striking result. 20% minus 20%. It's telling you that the optimal amount of wealth to risk is less than zero. Despite a positive expected return, the only winning move is not to play. So, in the end, math always wins. Remember the discrepancy, plus 6% on paper, but negative 12% in reality. Success in trading isn't about chasing high expected values, but it's about understanding the growth rate of your capital over time. Because in the long run, wealth isn't what you earn in a single trade, but it's what you survive across 1,000. So instead of relying on the volatility, you should respect it. Otherwise, the trap will find you.